Hello students, this is a lesson on probability of compound events. So what we've been learning about so far with experimental and theoretical probability is how we find the probability of one event happening. So when we flipped the coin, we look for the probability that the coin would land on heads or tails. When we rolled the dice sums, we looked for the probability, the experimental probability of the dice being a particular sum. Today what we're going to talk about is the probability of compound events. So that's when we have more than one event happening. So you should have your handout in front of you and you're going to fill in the notes as you go, and the teacher will pause the video as necessary to make sure you guys have time to write down your notes. So let's go ahead and get started. We have two different types of events. We have independent events and we have dependent events. So let's go ahead and get started with events. So this is the outcome. This is the probability when the outcome of the first event is not the outcome of the second event. So this is independent. If you think about the word independent, something is independent, it doesn't have any connections to something else. So that's what probability. So let's go ahead. I know you probably already copied down this definition, but we're going to go ahead and look at an independent event, and we'll come back to this slide in just a moment if you didn't finish copying that down. Okay, so I'm going to clear my ink real quick. So for this one, if I wanted to find the probability and the number cube producing an even number, you can notice that no matter what the spinner is, these are two separate entities. One has no impact on the other. So if I get a 4, that doesn't make it more or less likely that I'll land on pink, for example. It's the same likelihood. They're two separate independent events. Okay? So this would be an example of independent. So now we're going to go back to our notes. So again, the outcome of the first event does not affect the outcome of the second. An example of an independent event would be, what is the probability of landing on pink on a spinner with 3 color sections, then rolling an even number on a die? So pink, one of the sections was pink, although we were looking at orange. So go ahead and write down this example. What is the probability of landing on pink on a spinner with 3 color sections, then rolling an even number on a die? So we've got two separate events. Neither one of them are tied to the other. Spinner, doesn't matter if the die lands on one, it could still have the same probability of landing on pink. So what we're going to do, I'm just going to move this down a little bit, and we're going to take a look at this question as you've copied it down. What is the probability of landing on pink? So while you guys are copying that down, we're going to write down the formula for finding the probability of independent events. So the probability of A and B, the way we find the probability of two independent events happening is by finding the probability of the first event and multiplying by the probability of the second event. Okay? So let's go ahead and try this using the example that we have. So the probability of the first event, A, is pink, landing pink on the spinner. So we're going to look for probability of pink and an even number on the dice. Two independent events. So the probability of landing on pink is going to be 1 out of 3 because we have 3 sections. And the probability of getting an even number on a die, okay, out of the numbers on the die, 3 out of 6 are even. So that would mean 1 out of 2. Simplifying to 1/2 would be the probability of the number cube landing on an even number. And as you can see here, to find the probability of both events, we're actually going to multiply. So we're going to multiply those two fractions together. So the probability of a spinner landing on pink And the number die landing on an even number would be 1/3 times 1/2, which would be 1 out of 6 probability. And then, of course, we should go ahead and calculate that as a percent. So we just simply do 1 divided by 6. And I'm going to go ahead and round this to the nearest tenth of a percent. So this would also be 16.7% chance. So we have it as a fraction, and we also have it as a percent. And we'll do some practice in just a minute. But let's go ahead and look at the second type of probability. So the second type of probability is a dependent event. And you can probably guess that dependent means the opposite of independent. For example, each of you are dependent on your parents. So what they do impacts you, okay? Because you are dependent on them. You're depending on them for a place to live. You're dependent on them for food. So if they don't provide those things for you, you won't have them. So you can see you are dependent upon them until you're 18 or you move out of the house, whichever. Hopefully 18 comes first before moving out of the house. All right, let's go ahead and move up to dependent events. So dependent events then would be when the outcome of the first event does affect the second. Okay, so this does have an impact, whereas the other one does not have an impact. Okay, so for this one, we're going to go ahead and look at this example, which is you have 12 single socks in your drawer. 2 are white, 4 are black, and 6 are pink. What is the probability that you would pull out 2 black socks? So I put this up here. That's our example. Now you have 2 things happening, but think about it. If I take 1 sock out of my sock drawer, I now have fewer socks than I had in the beginning. So my first selection is going to impact my second selection. So go ahead and copy down this example here as we do it together. So we're going to copy this down. And then we're going to talk about the formula for finding the probability of dependent events. So the probability for this would be, you're going to find the probability of A and B, but this time you find the probability of the first event, which would be the first sock, and then you're going to find the probability of the second event after what you've done for problem A, or event A. That may seem a little confusing now, but it'll make sense when we get to it. All right, so now that you've copied down the problem, you've copied down the formula, let's look at it. So we are finding the probability of a black and a black sock, and then another black sock. All right, so the probability of getting 1 black sock, we know there are 4 black socks out of a total of 12 black socks. So the probability of that is going to be 4 out of 12. Now, that's our first probability, and we'll go ahead and think about simplifying that in a few minutes. But let's look at the second event, because here it says for the second event, we've got to look at what B would be now following A, because remember, this second event is dependent on the first. So let's think about what we would have now. We've taken out 1 black sock, right? Because the first selection assumes that we get a black sock. So we had a 4 out of 12 chance of getting a black sock. And for the second one, I now only have 3 black socks in my drawer. Okay, so that number has changed. Even though they're the same, it's black sock. Now, because of event A, I have 1 fewer black sock, and I also have 1 fewer sock overall. So this bottom number is going to be 11. Okay, because this is dependent on this. And we simply just multiply these together, just like we did with the last one. What I would do here is simplify my fraction, because 4/12 can be simplified to 1/3. Okay, and then I'll go ahead and multiply across. 1 times 3 is 3. And 3 times 11 is 33. And we can simplify that again, because 3 goes into both 3 and 33. So 3 goes into 3 once, and 3 goes into 33 11 times. So we have 1/11. And then we're going to go ahead and write that as a percent. 1 divided by 11 is going to be 9.1%. So there's a 9.1% probability, if you just randomly reached into your sock drawer, that you would get 2 black socks. All right, so now we've seen examples of both probability of independent events and probability of dependent events. And you may need to pause this if you need to continue copying these examples down. So if you need to do that now. All right, next what we're going to do is we're going to do a sort activity. You should have a sheet in front of you that has a table along with different types of events. You're going to practice sorting. So let's go ahead and look at that page. Okay, so look at this page. You have, yours might be in a different order that I have here, but you have all of these different events. And what I want you to do is I want you to go ahead and cut out each of these. And then I want you to cut out the side of the sheet that has the table. And then I want you to go ahead and decide whether each of these events are independent or dependent. So you're gonna cut this out. You're gonna cut out your pieces, and you're gonna go ahead and put the events where you think they should go. After you've done that on your own, I want you to compare in your group. And after everybody has compared in your group, I want you to play the video again, and we'll go over it. So the first thing you should do now is go ahead and pause the video. And you guys are going to do this activity by cutting out the pieces, placing them there where they should go, comparing as a group, and when everybody's about done, please restart the video. All right, let's go over these events and see how you did. So the first one that we have here that we're going to look at is rolling a 6-sided die 3 times in a row. Did you say that was independent or dependent? If you said independent, that was correct. What I get one time has no impact on what I get next time. So rolling it 3 times in a row, each time I still have a 1 and 6. 1 and 6 times 1 and 6 times 1 and 6. All right. Let's go ahead and look at this next one, selecting a letter tile, then selecting another without replacement. So this would be if you had a bag of tiles and you pulled one out, like say you're playing Scrabble, and you pulled one out, and I'm going to put it on my Scrabble board, and I'm going to now pick out another. So I have 2 different events for this. So once I take one tile out, that's going to impact my second selection. So this is going to be a dependent event. And a key is when you're looking for independent versus dependent without replacement. So when you see without replacement, often that's a clue that it's going to be dependent. All right, flipping a coin 2 times. Okay, heads or tails, I have a 50-50 shot, or 1 out of 2 the first time, and then a 1 out of 2 the second time. So this is going to be selecting a random card, then selecting another without replacement. So again, we've got that key, without replacement. Once I take one card out, I've changed my deck, what I have there. So this is going to be dependent. And again, my clue is going to be without replacement. My next one, selecting a letter tile, then selecting another one without replacement. Same thing as the other one, except for now I have letters without replacement. I think I have, guys, I think I may have put this one in twice. I think you may have one that's with replacement. All right, actually, you do have this one twice, so that was an error in the worksheet, but you've already used this one, so we don't need to use that one again. But let's look at these last two. You can just throw that one away since it's a repeat. But if it did say with replacement, okay, because you're putting it back in, if this was with replacement, it would be independent. But you can go ahead and get rid of that. All right, spinning a 5-section multicolor spinner 4 times. So each time I spin the spinner, we reset to spin it again. What I got the first time does not impact what I get the second. So this is independent. And then finally this one, choosing one player to be on your team, then selecting another. So once you choose one player to be on your team, you're going to have fewer players to choose from. So your second selection is going to be impacted by what you chose the first time. So this is actually a dependent event. All right, now that you've placed them where they go, you can go ahead and glue them. Now that you see the answers, and again, just throw away that extra one. And you can glue those down. And what I want for you guys to do is just keep these sheets, and then tomorrow, you're not going to have time to put them together in your notebook today, but tomorrow we'll update our table of contents and add these to our notebooks. All right, the last thing we're going to do in the video is you guys are going to, you should have one more sheet, and you have some compound events practice. So you have 4 problems. So at this time, I'd like you ladies to go ahead and try each of these problems. I want you to show your work on each of these 4 problems. You can try them on your own and talk about them in your group. And when it looks like most everybody has completed them, you can go ahead and restart the video. So at this time, go ahead and pause the video so that you can try these 4 problems. All right, let's go ahead and go over the work that you did. So for number 1, it says you roll a 6-sided die twice, and you're finding the probability of even and then odd. Okay, so if I want to know the probability of an even number out of a 6-sided die, I know that 3 out of the 6 numbers, right, are even. So that's my event A. And 3 out of 6 numbers are odd. That's my event B. And of course I can simplify these. So I can change this to 1/2. Half of my numbers are even. Half of my numbers are odd. And I'm simply going to multiply these 2 numbers together. So the probability of getting an even then an odd would be 1 out of 4. Shouldn't need a calculator for this, which would give you a 25% probability. And is this independent or dependent? Think about it. Independent or dependent? It's independent. So let's go ahead and label that. Okay. Number 2, you have 5 cards, each with a different vowel on it. You select one card, then another without replacement. Okay, so this is really important, without replacement. So because we don't have a replacement, that means our second selection is going to be impacted by our first. So this is going to be dependent. So our second selection is going to be impacted by the first. So first we figure out the probability of getting an A. Okay, we're assuming there are 5 cards, each has a different vowel. And so the probability of getting an A would be 1 out of 5. That's event A. And then we want the probability of getting an E. Okay, so our first event, 1 out of 5. And I'm going to multiply that by the second event. Now I've taken out an A. It's assuming the probability that we get an A. So now what's the probability of getting an E? All right, we still have 1 E left in the deck of cards. But instead of 5 cards, I now only have 4 because 1 card has been selected from the decks when we selected A. So we're going to multiply these 2 together, 1 over 20. So there's a 1 out of 20 chance, or 5% chance, that we would select an A and then an E. All right. Let's look at the next one. In a bag, there are 6 marbles. There are 2 reds, 3 greens, and 1 blue. You select 1 marble then another, and here's that key again, without replacement. So we're going to find the probability of getting a red, then a blue. So we're not replacing it. So whatever we take out, we're leaving out. So this is going to be dependent. Oops. Because the probability of getting blue is impacted by the probability of getting red, or the actual selection of red. So first we're going to look at how many reds. We have 2 reds. That's our first event. And we have 6 marbles. Okay, we can go ahead and simplify that to 1/3. And then we're going to multiply that by the second event. So the blue, I still have 1 blue. But now instead of 6, okay, that's what we had were 6 marbles, I only have 5 because I took 1 out for the red. So I'm going to multiply these together. 1 times 1 is 5. 3 times 5 is 15. So I have a 1 out of 15 chance. And 1 divided by 15 is going to be rounded to 6.7%. I'm just rounding to the nearest 10%. Both answers should be on your paper. All right, let's look at the last time. We're flipping a coin. So ladies, this should be easy to figure out whether this is independent or dependent. Okay, so the probability of all of these happening, the probability of getting tails, tails, heads, and tails is going to be an independent event, or these are independent events. So for our first event, the probability of flipping a tails, or a coin landing on tails, would be 1 out of 2, right? That's our first trial. Our second trial, again, I flip a coin. I have a 1 out of 2 chance. Again, this is theoretical probability. The third time I flip the coin, I still have a 1 out of 2 chance of getting heads, okay, because there's the same probability as tails. And then for my last one, I have a 1 out of 2 chance. So there we go. So I'm going to multiply all these together. If I multiply 1 times itself 4 times, we get 1. And then 2 times 2 is 4, times 2 is 8, times 2 is 16. So I have a 1 out of 16 chance of getting 2 tails, a heads, then a tails. So let's figure out what 1 over 16 would be. 1 divided by 16 would be a approximately 6.3% chance of that happening. All right, that's it for our video lesson. You're now going to receive a practice worksheet where you have some more problems that you're going to try by using the formulas and the notes that I've provided to you. Have a great day.